In 3.2a, we'll be solving linear equations, and basically what we're going to be doing is putting together everything that we already covered in section 3.1. So let's take a look at those steps that we follow. One thing I want to point out, you may use every one of these steps, and you may need only one or two of these steps, but you need to check at each case, in each problem, to see if you need to do the steps. So the first step, always take a look at each side separately and see if you can just simplify it, and I call that cleanup. And then what I'm going to say is that later we will be taking a look at if there are fractions or decimals, you can clear them, and you can do it in one step. Woohoo! Whoever thought you could get rid of fractions in one step? But in the meantime, we're going to put this off for a while, but we will come back to that. The second step is you want to get all of your variable terms on one side. So anything that's got a variable in it, you want on one side. And you want all your old little constant terms, which are just, remember, plain old numbers, on the other side. In order to move whole terms, whether they be variable terms or constant terms, you're going to be using the operations addition and subtraction. And then finally, we want to get that variable naked, and recall what that means. If you have something like 3x, you don't want to know what 3x is equal to, you want to know what x is. So if there's something in front of your variable, you want to get rid of it to get the variable naked, and you're going to use the operations divide and multiply to do that. Okay, I'm anxious to do some examples here. Let's do two examples. The first one, 3x plus 10 equals a negative 5. So we want to find, by solving this equation, we want to find the one unique x, what that number should equal, what x should equal, what number, so that when you plug it in for x in the original equation, you get a true statement. Okay, so let's take a look at this. First step, clean up. So I'm taking a look at this side first. Is there anything I can do to simplify that? No, we don't have any like terms. There are no parentheses, nothing to multiply out. So I'm saying, okay, that left-hand side is as simple as it can get. And I think you'll agree with me, that right-hand side, nothing to do there. So step one, we looked to see if we had to do it, but there wasn't anything to do, so we continue into step two. And in step two, we're going, okay, we want to get all of the variable terms on one side and all of the plain old numbers on the other side. When I look at what I have here, I see, well, there's only one variable term. There's only one term with an x in it. And it's already on the left, so I'm just going to declare my variable terms are going to go on the left, which means automatically my plain old number terms are going to be on the right. So, who's out of place? Yeah, this 10 is out of place because it's a plain old number, and so we want all the plain old numbers on the right. So, how we get rid of that 10 from the left, you look and see what's being done, and you just do the opposite, because that'll get rid of it. So that 10 is being added. So the opposite of adding 10 is to subtract 10. And we remember, if we do something on the left, we've got to do the very same thing on the right. So let's take a look at what's the result of subtracting 10 from both sides. On the left, this plus 10 minus 10 kind of cancel. They go to 0. 3x plus 0, well, we can just call that 3x. And on the right, negative 5 and a negative 10 is a negative 15. So at this point, yeah, all of my variable terms are on the left and all my number terms are on the right. So we're finished with step two. Now we got to get that x naked. What's in the way? That 3. And what is 3 doing to x? It's multiplying. So that tells you, basically tells you what you want to do. You always want to do the opposite. So the opposite of multiplying times 3 is to divide by 3. And if you divide the left-hand side, you just automatically have to divide the other side. Did that do what we wanted? These 3's will cancel, and what we have left over is our little lonely naked x all by itself. And on the right, the result of negative 15 divided by 3 is a negative 5. So let's just check that to see if we got an A on this. If x equals negative 5 is the solution to this original equation, and I'm going to have to clean that up just a little bit. Here's the original equation. Put it in red so we can see where it is. Then that means when we put negative 5 into x in our original equation, we should get a true statement. But we don't know that yet, so I'm going to put a question mark over the equal sign. And then we're going to chunka do a little bit of math. 3 times negative 5 is a negative 15. And we still don't know if that's equal to a negative 5. Negative 15 plus 10 is a negative 5. And now I can say, yeah, negative 5 does equal a negative 5. When we get a true statement, we know that we've done this problem correctly. So we have verified that negative 5 is the solution. Next problem. Okay, well, we have a little fraction here. We're not going to get rid of fractions just yet. So let's just start this as we did the previous problem. We notice that there's nothing to do on the left. There's nothing we can simplify, nor on the right. So we go step 1, finished. Step 2, I start to notice where we have our variable terms and where we have our number terms. So I see there's only one variable term and it's on the left. So I'm going to declare my variable terms are over here, which automatically means plain old numbers are on the other side. So who's out of place? You knew I was going to ask that. This little minus 4, he's a plain old number. We don't want him on this side. So we say, well, what's what's being done with that 4? He is being subtracted. So how do we get rid of that? How do we undo that? We do the opposite. The opposite of subtracting 4 is to add 4. And we know we got to do it on this side as well. So the result of that is 1/2 x minus 4 plus 4 equals 1/2 x plus 0. So I'm just going to write that as 1/2 x equals, and on the right we have 7. So we're almost there. We have 1/2 x equals 7. Most of you at this point could say, oh, I bet x equals 14. So let's see how we can get there if we didn't know that. Now, I'm going to draw a line because I'm going to ask you to recall something. And I'm going to do something in red here in our problem. And then I'm going to kind of put it aside and show you the shortcut to do that. All right, so we've got x and we know what we're going towards. We're going towards x all by itself and naked. So what's in the way? 1/2. What is 1/2 doing to x? It's multiplying. So we want to do the opposite. What's the opposite of multiplying by 1/2? Dividing by 1/2. So this is what we're going to be doing. We're going to divide by 1/2, divide by 1/2. Now, many of you may be going, ooh, that's kind of ugly. That's kind of scary looking to me. So let's do a little bit of recall, and I'm going to show you that you already know the shortcut here. Recall back when we were talking about fractions. If you have whatever number and you're dividing by a fraction, and in this case it's 1/2, that is the same thing as taking that same first number and multiplying by the reciprocal. So 2 over 1. So back here in the problem, instead of writing this as dividing by 1/2, what we're going to do is just be very clever and say, oh, but wait a second, dividing by 1/2 is the same thing as multiplying by 2. So I'm going to take this, I'm going to multiply this side by 2 and this side by 2. What happens over here on the left? Well, if you want to, you can put that over 1. 2 times 1/2, everything cancels. We're left with 1x, which is what we wanted. And on the right, 7 times 2 is 14, and that's what we already suspected was our answer. Okay, and if you don't mind, I'm just going to say the check is left to the student. Okay, so I will see you for some more examples in the next video.